Peter, and I'm going to talk to you about recompiling JavaScript without restarting it. I'm a Dutch JavaScript developer. You might have heard me from JS1K. I organize that, and I build a variety of tools, JavaScript-related tools. I work for a company called Surfly. They do remote desktop in the browser, but that's not what I'm going to talk about today. So first we start with a demo. And so we're going to start with reloading. Oh dear Lord, no. So we're going to start with re-enabling Nginx. It's really exciting, I know. It's like, and there we go, I hope. There we go. All right, so on the right-hand side, you see a small animation, basically, right? The point is that it turns and it moves. And whenever I edit anything, even like adding a space, it's going to restart this code. There's a loop down here. Sorry it's not indented. It seems I forgot that. But if I change it, it will reload the code and it will restart from scratch. So now let's look at how that will look if you were to recompile it. Apparently that crashes. Wow. All right, so that's not cool. Okay, sure, no problem. So let's open the console, turn it bigger and bigger, and all right, so it's going to repeating, and whenever it's going to start, it's going to do foo. I'm sorry, I had a visual thing and it's apparently not working. So whenever I want to change it now, it's not going to print foo. And if it would print foo, then the program would have restarted. And as you can see in the console, it's well, printing out the new stuff. I can do pretty much anything, even like closures. But let's just try something quickly. Such a pity. Oh well. Okay, so no fancy demo there. Let's continue with the slide. Basically what it is it's compiling JavaScript on the fly while maintaining access to closures, which is something that's not that trivial to do. Obviously no restart of the application is required. So if you're like building a game, then you wouldn't have to go through your start menus and whatever to see your change up and running immediately. The library, at least, is a lazy evaluation, so it's compiling once, and it's only going to recompile when you change it. It's a generic approach, meaning that it will work with pretty much any JavaScript. There are obviously some limitations, but I'll cover those later. So when I talk about compiling in JavaScript, what do I mean? When you have a function, you're actually compiling JavaScript because you're preparing code to be ran. So when you're creating a function to be invoked later, you're actually compiling JavaScript. So that's what I mean when I say compiling in JavaScript. All right, so I'm going to do this live coding thing, and it's going to be awesome, I'm sure, just like the previous demo was. So this one, no, this one. So we have a simple set interval, and it's printing hello JSConf, add a forgotten 500 millisecond. And so that's what it does. Now, the first step, because I'm going to recompile those functions, is I'm going to wrap those functions. So I'm going to create a new function called, well, you know, and it's going to return that function that I just sliced out. So this is the same as I had before. You know what? I should probably. So this is the original code that we're. I press a button. I shouldn't be pressing buttons. Okay, so whatever. So this is the first step, and of course it still works, still does the same thing, except I sliced out the way that the function is being passed on. So next step would be to actually compile the function. And how do we compile functions in JavaScript? Dynamically. Eval. Now eval is evil, so let's just use the semantically more appropriate way to do it through function. So we're going to do like that, and that should return the same function that we had before. So let's try that. Still working, all right. Okay, so let's abstract this a bit by putting it in a global variable so that we can access it later. So this is still the same thing as before, just a bit of abstraction, and it still works. All right, so let's make this into a function ID parameter. It's being passed on, 0, because it's still the first function in this array. It still works. Now, are we able to recompile at this point? Because basically all we'd have to do is change this, right? Because this is being evaluated and executed. So let's just see if that works. Since we have a global, we can access it. Oh, not capital. It doesn't work. Why is it not working? This function, get function, is only being invoked once. It's not being repetitively being invoked. So when I change this, this isn't being picked up. So what I need to do is I need to return a function that does a recompilation. So now we can see that it's recompiling but not executing. So in order to fix that, we recompile, and we immediately invoke. All right, that's what these are going to do. So now we can see that it's compiling and printing. All right. So now, is it going to work if I try to recompile? Yes. So this is recompilation as its most basic primitive form. You're changing the runtime, without actually restarting the code. Now let's see. We need to properly invoke this because if we're going to do arguments, then this is not going to work. In fact, what are other things that might go wrong here? I mean, if you're looking at recompilation in this approach, what kind of code, if we're looking for generic support, what kind of code might not work? Anybody? All right. No. Good thing I put a few up. So function arguments are not going to work because they're simply being ignored right now. Closures aren't going to work because you don't have access to them. And that's probably like the prime thing in this whole approach. Function declarations don't return a value. So if you would wrap those or replace those, then that would be pretty much dead code. Named function expressions are a special case because the name of the named function expression it's handled in a slightly different way. And of course there's performance, because if you're going to repetitively go into eval code, it's going to hurt your performance. So let's try to fix those cases. First, for arguments. So arguments is quite simple. We're going to change this structure into a set of objects. I shouldn't be typing object. All right, so it's going to be args, and then function accepts multiple parameters, and only the last one is supposed to be body. So let's do args and change this to body. And this should still work and still do the same thing as before. Note that we're just passing on one args as a string, but we're going to fix that later. No, it's still working. Hello, JSConf. So arguments. Let's say we take a new demo. I, of course, prepared a few of those. So let's try to use this example. Now this is, of course, still a simple example. And it's going to repetitively print out or call a log function, which is just an alias, which has a one argument text. So if we're going to replace that the same way as we did before, we need to slice out the body. Copy that into our data structure as before. We're going to add a text parameter. Then we have get function 0 because it's the first function that is going to exist in this data array. And then the second object has no arguments, function. And so, did I do everything? Oh no. All right, so now we have basically two get function calls, and they're going to return, the functions that are generated through whatever is in this array. So let's see if this works. Oh. It doesn't work. And why doesn't it work? Anybody see that? Look at these two characters. What's missing here? The actual arguments. So remember that this function is the function that's being returned and being invoked where the original function would have been invoked. All right, so if we look at the original code, I've replaced this function basically with this function. And so that's being invoked. And in order to pass on the arguments as originally intended, I need to change this piece of, this snippet to the standard apply context and then array prototype slice call arguments 0, or whatever way you want to do this. So in a nutshell, this now is going to invoke this generated function as if it was invoked originally. Same context, same arguments. As far as the running code is concerned, nothing changes. And now it should work. There we go. Okay, so now we can still update this. So we have data 0 is this text, or this body. And let's try to change that by, say, just appending some kind of argument. And it's failing because, oh, no, wait. It's in quotes? Oh, because I'm not quoting it, haha, yeah. No, oh right, no, I know why this isn't working. So I changed the data structure. And now, so I've changed the runtime from hello text and just appended the foo without restarting the application. So arguments are preserved, and we can mess with that. All right, so that's one step. So then if we have had arguments, the next step would be closures. All right, so we fixed for function arguments. Let's look at the closures. Closures is going to be this snippet of example. Oh. Let's put it up here. So we are going to have a function that's going to repeat whatever is being passed on. So this function will be called below, and then set interval will repetitively log out whatever is being passed on. So note that text in here is a closure over the text that's being passed on. So if I'm just going to replace it as I did before, actually I don't think I need to replace the first one because it's still log text, so that's remains the same except for the function, for the argument, because that's now in the second function, which is the whole. So this is like the second function now, and it's going to wrap this get function. All right. So now let's see if this works. No, because text isn't defined, and the reason it's not defined. Can anybody figure it out like right now? Why text would not be defined there? Okay, so yeah, it's function. I heard somebody say it over there. Function is actually a indirect eval. All right, so it only has access to the global scope. If we look at direct eval and indirect eval, the main difference, at least in this context, is that direct eval will have access to the lexical scopes. and because we're using function over here, it's not working. So let's change this to eval. So we're going to change eval. We need to add the function boilerplate now. Arguments, body, closing parts, and the rest remains the same. Sorry? Yeah. All right, so let's see if this works now. It still doesn't work. What did we forget? So eval is lexical scope. So even though we're doing direct eval right now, it's not going to be able to access text because text doesn't exist in this function, it doesn't exist in this function, and it doesn't exist in global scope. So that's why at this point it's still throwing a failure. So in order to solve this, we're going to do something like this. And let me just give me a second. Well, let's do it in order. So we're going to add a compiler. Let me just do this on a new line. Okay, the rest pretty much remains to be the same thing here, and at least. And then whenever we do get function, we pass on this compiler as an argument. And this requires now a argument because, I mean, this call is this, you know, this passed on. So rather than eval, we're going to use this compiler to compile stuff. And in global scope, we just pass on eval because we don't care about direct or indirect from global. Okay, so is it going to work now? I certainly hope so. Hooray, okay. So at least it's working now. So let's see if we can actually change the closure, because this text over here is a closure. Remember that this function doesn't have a closure, a text argument. So let's just try to change it. Not remove it, change it. And see if we can mess with it. So body equals dot. And it works. So we're able to recompile code now, even though there were closures in there. So it maintained access to those scopes. So we fixed closures. Now the next part is function declarations. Function declarations require a preprocessor step. So if we have like a function foo, then what we actually need to do is rewrite this to var foo is function, they're equivalent. And the only other thing you need to take into account is that you need to move this line to the top of the scope, because that's basically what JavaScript does as well. So JavaScript will hoist those function declarations, and you can just use any kind of parser to rewrite this part and make it equivalent in terms of JavaScript semantics. So that's for me at least, that's a very simple, trivial way of getting rid of the function declaration problem. Use a parser. For named function expressions, it's slightly more complex. So you'd have, like this case. Actually, it's not set interval. So the right way of doing the paint loops with timers, if you were going to use timers anyways, would not be set interval, but set timeout, and then you do like a. And of course, this would be like the computed depending on whatever. Okay, doesn't matter. So this is how you would do your paint loop. And then the problem with this approach in terms of recompiling is that you don't get to change repeat anymore. So that value of repeat is just being executed or just being assigned once. On top of that, of course, names of named function expressions have more weird semantics, but that's the main point, the main problem here. So what we do here is we're going to rewrite the named function expression as well. And so rather than this, we're going to do a actually, we're going to wrap it in the function. So we're going to do this, and then this would be the actual code. And then we're going to return this function. So we're going to basically rewrite this, and that way we get rid of the named function expression while maintaining the runtime semantics of a named function expression. And this way we can actually use our recompilation stuff. So let's quickly try this, just to prove that it does work. Sorry. So we'd have this, and then we're going to wrap this body again. There are no arguments to this function, and the name we don't need anymore, because that's going to be abstracted away in our rewrite. Right, I should have rewritten it first, huh? Right. So this is the rewritten part of the set timeout, and now I need to wrap it. I can still maintain the first part, I guess, and then use get function 0. This is still the first function up here. I think this is good. And then we're going to wrap the new function as well, of course. And so it's going to be get function 1. Oh, of course, we need to pass on a compiler. And of course the compiler here as well. And no argument. I think this will work. I hope, anyways. Let's see if it works. It doesn't work. Does it need to be invoked immediately? No. All right, well, I guess you're just going to have to assume or take my word for it that it works. I don't think I'm going to be able to solve that in right now. Anyways, the solution does work because the semantics should be equivalent. All right, so we've solved the named function expressions. And then for performance, we can actually extend or postpone it. So let me revert so that we had it what it was before. I think this was working. Yeah, okay, so, and we can change that to this. Yeah. So what we do is, instead of compiling it every time in this step, basically, we cache the function that's being invoked, and then we check whether it's up to date. So we're going to add a closure, or actually two closures, I guess. That's the function, and that's the version. We're going to do a version check. No, not equal to our local version, and then we're going to check whether function exists at all for the first time. And if it doesn't, or if either of the cases isn't true, whatever, then we're going to compile it, cache that function. Let's see, we need to move this away, sorry. Update the version. I think this is fine. And then apply return func apply. And then all we need to do is update the, sorry? Oh, I'm doing and. Yeah, that's correct. Sorry. And I need to add the version to the data object, which can be just like a All right, so now it's only going to update the compilation, and we can sort of prove that, I suppose, by checking it here. And so this step should only be invoked now. So the actual calling of eval should only be called now when the code is changed. I'm not sure why it does it twice right now, but whatever. But as you can see, it doesn't compile now. And so what we can do now is we can change the body of the code, and it doesn't recompile because it doesn't see a new version. So as soon as we do that, and it can be anything. I mean, it can be foo. It doesn't really matter. It just doesn't need to be the same as before. And then you can see it recompiled, and then it actually recompiled. So it's a sort of lazy evaluation, and still, recompiling. Okay, so that was the last part of the main issues. I had a slide for this, awesome. So the first is direct eval. The main trick to this approach is basically a indirect direct eval. All right, you're caching a function. Well, that's what we're doing in this. Why am I not? In this part, right? We are creating a function on any scope of our new functions, and that makes the $compiler variable available on any scope. And that's why we can do the get function compiler here, which basically just returns this function. And because this is a direct eval at that point, it's going to have access to all the variables, and that's why closures are working. There's actually one problem with this snippet of code. Can anybody see what? What's going to happen at runtime at some point? I doubt Douglas Crawford is going to use this at all. All right, so what happens if we recompile this and we do S? What's going to do? It's going to see that variable because it has access to closures. And because we're adding a new function, it's actually kind of adding a new scope. And if we declare variables in that scope, they're going to show up in this recompiling step. So changing the version, and we can now see that it's actually printing out the log. So we're polluting the scope. Of course, we're also polluting the scope with a compiler function, but that's something that I can't fix. For this one, you can fix it by simply removing this argument and saying, I mean, you're already using eval, right? So you might as well use arguments. All right, so now it works, and if we change it to that, it's going to cry because as is no longer available. Of course, we can still print out, say, compiler. But that's, again, use like Greek letters or something, I don't know. S is not defined. And now it's just going to print that compiler function. But this is the main trick. Create a function that has a direct eval and maintains access to the local scopes. Yeah. So basically, recap. It's a approach that works generically. It works for pretty much any kind of code. You can recompile it, you can change it on the fly. If you've seen Brett Victor's talk, Inventing on Principle, he does this at some point he does this loop, and he changes it, and he changes the number of iterations to, I don't know, whatever, to change the number of leaves in the tree. And the first time I saw that, I was like, that's not possible, you can't do that. And then later I had to disprove myself, of course, because it is possible. It's just, it takes magic, a bit of magic. So on every scope, you inject a new function, a compiler function, which has a direct eval, and by which you have direct access to all the scopes, which maintains access to closures, and that makes this work. And inside that, you have some rewriting magic for like function declarations and other nasty things that might screw this up. So some open issues. The biggest problem here is inserting new functions, because you're mapping functions one-on-one, right? And I have the library where I do the, I abstract this everything away, so you can just, as you can see in the recompiler demo that doesn't really work. You can type here and it will replace all the codes, but it's going to assume that these functions are going to be in a certain order. So if you add a new function, inject it somehow, it's going to trip up, simply because it's going to run to put this body, or actually no, this body into this body. And so it's something that I don't think is very easy to solve. I've tried to do a diff, but a diff will help you only so far, because there might be changes that are spread on multiple parts in the code. And in that case, you don't know which functions to replace. So that's like the biggest problem with this approach. But as long as you're not inserting any new functions, everything's going to be fine. The minor issue is, of course, the variable clashes that I explained before. And it's actually very hard to explain. People don't seem to get that you can't really go ahead and change the global code, right? I mean, if there's no way that if I would, at runtime at least, if I would do this, var foo is bar, and at runtime I would recompile this and to say this like G, it wouldn't be picked up, because it's only picked up by code that's re-evaluated. Okay, so this approach only works if you have functions like, well, callbacks that are going to be re-evaluated or actually re-invoked at some point. Any other code, which includes any global code, it's not going to work, or at least it's not going to be useful. It's going to work, but it's not going to do anything. So that seems to be hard to get across, unfortunately. So the code is going to be available on GitHub, as usual. I will push it later if GitHub allows me to, and otherwise slides will be in there as well. And yeah. So are there any questions? I have like 0 minutes left, so that should be fine. Okay. Otherwise, I'll be out there, and yeah, thank you.